So I'm going to ask you to stop the video and have a go at this little exercise. You've got the question, the reaction of burning glucose. And normally I would give you the reaction already balanced and I would ask you things about the reaction, but here I'm going to ask you just to practice a little bit, to do an extra step. I'm going to ask you to write the balance equation, to tell me if this is an endothermic or an exothermic reaction and justify why you think it's endothermic or exothermic. And I'm also going to ask you to calculate the energy produced or absorbed, depending if you decide that if it's exothermic or endothermic, when you 2.5 moles of glucose react with enough oxygen so it all burns, or how much energy is produced or absorbed, depending if you decide that the reaction is exothermic or endothermic, when you have 10 grams of glucose burn with excess oxygen. And the reason why I'm telling you with excess oxygen is I'm telling you, okay, well, it doesn't, you are assuming that all your glucose reacts to produce CO2 and water. You don't have to worry about running out of one of the chemicals. Stop the video now, please. Okay, I hope you had a go at doing this exercise. So the first thing the problem asks me is to balance the equation. So off I go. I look first, you can balance equations in any shape, in any way you want, and different people have different methods. The way I do it is I tackle first all atoms, or any atom that is not hydrogen or oxygen. So that's my first step. So I try to prioritize first the atoms that are not oxygen and hydrogen. And then as the final steps, I look at hydrogen and oxygen. And if I have an element, like in this case is the oxygen, if I have an element that is on its own as a reagent or a product, then I leave it until the end. And that is because any number I put in front of that element, in case of oxygen, will not ruin my balancing of the other atoms. So I tend to leave that until the end, because whatever number I put in front of the oxygen, it will only affect, in the molecule O2, it will only affect that molecule O2. So I've got 6 carbon atoms on the reagent side, and I only have 1 in the product side, the CO2, so I've got the 6. I have a look at the hydrogen, and I have 12 atoms of hydrogen in the left-hand side, in the glucose, but I only have 2 in the product side, so here I put another 6 here in front of the water, and then I tackle the oxygen. So in the products, I've got 12 atoms of oxygen that come from the CO2, from the 6 molecules of CO2. And I have 6 atoms of oxygen that come from the water. So in total, I have 18 atoms of oxygen on the right-hand side. 12 come from the CO2, 6 from the water. And if I look at the right-hand side, the number of atoms in the molecular glucose is 6, and then I only have another 2 from the oxygen. So I've got 8 and I need 18. I've got 6 fixed in the molecule of glucose, so the other 12 need to come from the O2. So if I put a 6 in front of the oxygen, of the molecule O2, that gives me my 12 atoms of oxygen. And now I just have a quick look, 6 carbons on the left-hand side, 6 on the right-hand side, 12 hydrogens in the left-hand side, 12 in the right-hand side, and 18 atoms of oxygen in the left-hand side and 18 in the right-hand side. So that the equation is now balanced. The next step, the question was asking me was, is this an endothermic or an exothermic reaction? And justify my answer. Well, I go to and look at the change in enthalpy value, and it's minus 2,816. The minus tells me this is an exothermic reaction. And why do I know it is exothermic? Because the value of enthalpy is a negative number. That's what I know. Is that minus is what tells me this energy is going to be released. The next thing the question was asking us is, okay, well, what happens if you have 2.5 moles of glucose? And we mentioned in a previous slide that enthalpy or all these functions are extensive properties. It means that it depends on the quantity of the chemical you have. So what the question is telling me is that if I have 1 mole of glucose, So if I don't have a coefficient here, it means I have a 1. Releases it has an enthalpy of a reaction of minus 2,816. If instead of having 1 mole, I have 2.5 moles, I will release 2.5 times that value, which is, assuming I haven't got it wrong with my calculator, around minus 7,000 joules. So this is how much energy would be, in this case, released, because it's an exothermic reaction, when 2.5 moles of glucose react with oxygen. The next step asks me about grams. It tells me, okay, what if you have 10 grams of glucose? And that is not as straightforward, because a chemical reaction does not tell me about grams. It tells me about moles. Moles and molecules. What it tells me is 1 molecule of glucose, 6 molecules of oxygen make 6 molecules of CO2 and 6 molecules of water. Or 1 mole of glucose, 6 moles of oxygen give me 6 moles of CO2 and 6 moles of water. So chemical reactions talk about molecules, if you want to look at the sort of microscopic state, or moles if you want to look at them in a macroscopic state. It doesn't tell you anything about grams as they are. Those coefficients are not grams. It's not 1 gram of glucose and 6 grams of oxygen. It's 1 mole of glucose and 6 moles of oxygen. And the question is telling me, okay, you've got 10 grams. So my 10 grams as they stand are useless to me. I need to make my 10 grams of glucose into moles of glucose. How do I do that? Well, I use the formula for moles. The number of moles is the mass divided by the molecular mass. I know I have 10 grams of glucose because the problem tells me that, and I know the molecular mass of glucose. What I did was just look in Google what was the molecular mass, and it's 180. But if you don't want to look in Google, if you want to practice, you can work it out by looking at the atomic masses of all those atoms. Carbon is 12, and you have 6 of them. Hydrogen is 1 atomic mass unit, and you have 12 of them. And oxygen is 16 atomic mass units, and you have 6 of them. And that gives you a grand, 16, not 12. And that gives you a grand total of 180. So 10 grams divided by 180, which is the molecular mass of glucose, gives you a grand total of, give or take, 7.6 10 to the minus 3 moles. And now I know, because now I'm in moles. In moles, the equation tells me about moles. If I have 1 mole of glucose, the enthalpy of the reaction is minus 2,816. If I have 7.6 10 to the minus 3, then I will release approximately 214 to 115 kilojoules, depending on how you play with your calculator and how many decimal places you keep in your system.